Here we go. We're going to do minimum spanning tree, which has to do with networks. And I made up a problem that has to do with sprinklers. And here's the question. If I have a network where each node is going to be a sprinkler, what's the shortest way I can connect all of those sprinklers? Let's say we have this network here, and all of those numbers on there are in meters. Okay, so for minimum spanning tree, I'm going to use something similar to Prim's algorithm. And it looks kind of messy, but we do have an algorithm. We do have a mathematical method for connecting all of these nodes. Remember, these are the nodes. That's an edge. And for this, minimum spanning trees, when I connect all the nodes with the smallest sum, can't have any closed loops, otherwise it's not a tree. And how I'm going to do this is I'm going to look at all the edges, highlight the cheapest one, and then when that edge is highlighted, I'm going to look at the nodes that highlights, and I'm going to connect the cheapest edge from there. I continue that until I have all the nodes connected, and then I add up each edge, each value. Okay, so let's use Prim's algorithm to figure this one out. And I look all on here, and the shortest edge I have is going to be, I think it's 9, this guy right here. Okay, scratch that. It's not 9. It's 5. Thank you, class. So I'm going to highlight those. Let's make sure that it is 5. Okay, so with this highlighted edge, I have, okay, those are my highlighted nodes now. And I go from those two highlighted nodes. So each step, it becomes more complex because more nodes are highlighted. So from C and H, what are the shortest ones from C and H? Well, from C I've got 9, 16, 20, 17. And from H I've got 23, 10, and 25. So it looks like now the shortest edge is that 9, which I made a mistake on the first. Okay, so I highlight that, and now I highlight that node B. So now I've got 3 nodes that are highlighted. What's the shortest one off of those 3? I've got 11 off of here. I've got 20, 17, 16, 10 up there, 23, 25, so it will be this 10. Now F is a highlighted node. F has a couple of long ones coming off of it, 19 and 22, probably don't want that. 25 coming off of H, don't want that. 17, 20, 16, or 11 off of B, I think it's 11. I'm going to go with 11. That highlights A. Now I've got 1, 2, 3, 4, 5 nodes highlighted, and I don't want any closed loops, so I don't want to highlight 16. What's the shortest one? There's 25, 20, 17, 19, 20. I think it's 17 off of C, because I don't want to connect 16 because I would make a closed loop. I already have these sprinklers connected. I don't need to connect them again. So I'm going to say it's 17. That highlights E. And out of all of these nodes that are highlighted, I don't want to connect 19 because that would make a closed loop. I think it's 12. No,
8.
Scratch that. It's 8. That highlights D. And I've got 2 more sprinklers to connect. And what's the shortest way to connect I? It's not going to be 23. It looks like it's going to be 12. But are there any other shorter links anywhere? Because that's how this algorithm works. I've got a lot of highlighted nodes. And I think the shortest one I have at the moment out of all those is 12. Is that right? I think so. So I becomes highlighted. And the last node I have is this G way up there. And that's got some long ones. It's got 21 and 22. And those are the only edges that connect to that one. So it has to be D to G. And now I've got all the nodes connected by the shortest path. And if I said the number represents the distance in meters, what is that spanning tree? What's the length? Well, I'd find the sum of all those paths and just write it somewhere down below and saying here's the shortest way to connect all the sprinklers. Okay, so I sum all the sides up, making sure I don't skip any. Got my sprinklers flowing. I get 93 distance in meters, which I didn't say, but let's just say it's in meters. And that's how we do spanning tree using Prim's algorithm, connecting all of the nodes. Of course, I don't need to connect every path because I don't care about that, just the nodes. There it is. See ya.
I